A Bernoulli equation is of the form y prime plus p of t y equals q of t times y to the n. And I've specified here that the p and q stand for functions of t. And the derivative, of course, is implicitly understood to be with respect to t. Now, if the equation was just y prime plus p times y equals q, where again p and q are functions of t, this would just be a first-order linear non-homogeneous equation. We could integrate it, integrating factor e to the negative integral, e to the integral p of t dt, get the left-hand side into the form of a derivative of another function, etc. But we've got that pesky y to the n in there. Now, these are common equations. They occur a lot of times, for example, if you have a nonlinear drag force. You have a lot of physical situations in which you get powers of y over here. The trick to solving this equation, it's one that most people just aren't going to think of, but the trick is going to be to let v be a new variable equal to y to the m, where m is some number that we don't yet know. Now that makes some sense, letting v be a power of y, because it's a power of y that's messing us up. But be that as it may, if we let v equal y to the m, then what do we have? We have, well, let's write that, dv dt equals the derivative with respect to t of y to the m, which equals m y to the m minus 1 times dy dt. Now, our equation is in terms of y prime, which is our dy dt. Our new variable is going to be v, which is y to the m. We need an expression for y prime in terms of v. That's really not hard to do. First of all, we note that dy dt would then equal 1 over m times y to the 1 minus m times dv dt. The reciprocal of y to the m minus 1 is y to the m minus 1. The reciprocal of y to a power is y to the negative power. And the negative of m minus 1 is 1 minus m. Now dy dt is equal to this, but we still got a y in here. We want to change our variable to v. We want to be able to express this entire equation in terms of v with no y's included. So how are we going to do that? Well, since v equals y to the m, it follows that y equals v to the 1 over m. Again, you should be aware of laws of exponents by this point in your mathematics education. That should be no problem. So what we have now is that our dy dt is equal to 1 over m times v to the 1 over m raised to the 1 minus m times dv dt. Now we have our y prime expressed in terms of v. We can simplify this expression one more step. We can write this as 1 over m times v to the quantity 1 minus m over m times dv dt. We could distribute the division by m or the multiplication by 1 over m and get 1 over m minus 1, but it's going to be more convenient to leave this in the form of a fractional expression. Okay, so there's our expression for y prime. Now what does that do to our equation? Let's kind of summarize that on the original sheet. The results here are that y prime is equal to this, and of course that v is equal to this. Using these two results, we're going to be able to rewrite the equation. So leaving out all the steps in between, y prime is 1 over m times v to the 1 minus m over m times dv dt, and I'll just write that now as v prime, and y is v to the 1 over m. Our equation therefore translates into the equation. This is y prime, that's going to be 1 over m v to the quantity 1 minus m over m times v prime plus p, now I'm going to write that as p of t. Y is v to the 1 over m, and that'll be equal to q of t multiplied by y to the n. Y is v to the 1 over m, so this is v to the 1 over m raised to the n, which is of course v to the n over m. And now if we don't get too confused with our exponents, we can put this into the form where we have v prime plus something times v, and we'll see how that works in a minute, and that's going to equal q of t times v to the n over m. Well, there's a little more to it, and we'll see what that is. Okay, now, just writing out a couple of intermediate steps here on a separate sheet. We're going to multiply both sides by the reciprocal of this. So we multiply by what? M over 1 times v to the m over 1 minus m power. Okay, we multiply by v. See, now I just did something there. Let's be real careful, because I've been known to do this before. Okay, we multiply by what? M over 1 times v to the negative of 1 minus m over m. Okay, we don't take the reciprocal power, we take the negative of the power. If we multiply this by this, we get v to the 0, the v goes away, and of course the m goes away. Now when we do that, what are we going to get? We're going to get v prime here, and then it's going to be plus p of t. We're going to have the factor m, and we're going to have this. Well, that's going to give us m times p of t times v to the what power? It's going to be the 1 over m power plus this power. So it's going to be v raised to the 1 over m plus minus 1 minus m over m. Maybe wrote a little bit more there than is really necessary, but this is correct. And that's going to equal q of t multiplied by v to what power? And there's going to be an m. So it's going to be m times q of t times v to what? It's going to be the n over m power minus the 1 minus m over m power. So being careful to write out our powers. There's nothing difficult about this. We just got to be careful to apply the rules of exponents very carefully. We get v prime plus m p of t times v raised to what power? Well, 1 over m, well, okay, minus 1 minus m over m. 1 over m is 1 over m, so we're going to have 1 over m minus 1 over m, and then minus m over m is plus 1. This comes out v to the first power. Make sure that's a 1 and doesn't look like a prime. Look at what we've done. We've gotten the left-hand side into the form of the left-hand side of a first-order linear equation. The right-hand side, of course, is not going to come out 0. So it's going to be non-homogeneous, but at least now we have something here. Now, that's going to be m times q of t. And then what are we going to have here? We're going to have v to the n over m minus 1 minus m over m. Let's just do a little side calculation here. That's going to give us n over m minus 1 over m plus m over m, which is m over m is 1, and n over m minus 1 over m is n minus 1 over m. So over here we're going to get v to the 1 plus n minus 1 over m.